Thanks, Uday. So a little different. This is not about a creative industry, but about an underlying wireless technology that delivers connectivity from machines back to networks. So I want to spend a short while telling you about the technology first, and then looking at some of the issues in launching a technology and trying to make it into an open global standard, which do rely on media and connectivity and all sorts of other interesting things to do with it. So the company Newell was started about 18 months ago on the hypothesis that there is a huge demand for connected machines out there. There have been predictions that say that by 2020 there'll be 50 billion connected machines in the world. And that doesn't sound so hard to imagine if you think actually there's 5 billion people with a cell phone. So 50 billion connected devices is only 10 per person. And I suspect if you look at your home and look at how many wireless devices you have in your home, the answer is a lot more than 10 by the time you add up your Bluetooth and your Wi-Fi and your cordless phones and your garage door openers and everything else you've got. So the concept of having another 10 devices, another 10 connected machines is relatively straightforward. So there's a great market for billions of devices. But we've not yet seen this market materialize. And the reason that it hasn't happened yet is because if you are a manufacturer of a device, let's say a cat collar that wants to track a cat or something, and you want to go out today and buy a chip to drop into your device to provide it with connectivity wherever it is, at low cost and very simply, you just can't do that. You can, of course, connect machines over short range using Bluetooth or Zigbee or Wi-Fi, but that's not much good if you're trying to track something that goes outside of the home, or you're trying to connect to something like a smart meter. And the reason why we've not yet had a single technology that can deliver wide area, very low cost machine connectivity is actually predominantly down to radio spectrum. So in order to make this connection, you need radio spectrum that provides for great penetration. It needs to be low frequency, so the signals go quite some distance. It needs to be relatively plentiful, so that you can connect these 50 billion devices without congestion in the system. It needs to be globally harmonized. That's the only way you can generate the economies of scale to get the chip costs down. And it needs to be relatively low cost, because you can't afford at this stage in the game to spend billions of dollars in every single country in the world in order to get a new system up and running. And the big trigger is the advent of some new spectrum or new access to spectrum called white space spectrum that is now available in the US, is becoming available in the UK this year, and will gradually become available throughout the rest of the world. And that spectrum is actually the spectrum that is interleaved in and around the digital TV transmissions in the 400 to 800 megahertz frequency band. But you can't use that directly. It has a number of problems associated with it. In particular, it's polluted by TV transmissions, so you need to find a way to work around the interference they cause. And it's going to be unlicensed, which means it could be used by other users, just in the same way that the 2.4 gigahertz Wi-Fi Bluetooth band is unlicensed. So you need a mechanism to work around interference from other users. And hence the reason why we concluded the need for a completely new technology, custom designed for machine communications, which are quite different from people communications, and also designed to work very effectively in that white space frequency band. So what do we need to deliver to make a system work really well for machine applications? Well, first of all, enormous battery life. So you typically need to deliver 10 years battery life off a single coin cell battery for a lot of machine communication applications. So as an example, a sensor that you might deploy in a smart city, let's say to measure whether a parking space is empty or not. You don't want to be going back and recharging the battery on that every week. You need something like 10 years battery life for those kind of systems. Very low cost. All of the work we've done suggests that you can't really support a chipset cost of more than about $2 for many of these machines. There's one or two that support more than that, but the vast majority of these applications require that you get the chipset cost down to about $2. put that into perspective, the cheapest 2G cellular chipsets are more like $10, and then you go up to sort of $30 for 3G, and at the moment it's $60 for 4G. So getting on for an order of magnitude less than the cost of a cellular chipset. You need to have exceptionally good coverage. So if you take smart metering, for example, it's not sufficient to say we can hit 90% of the meters, because that still means you've got 10% that are a problem area. You need to be able to get to 99.9% of the meters. And those meters are often buried deep inside homes, so you need to be able to get into the building and get to the meter. Cellular gives you about 98% outdoor coverage, but only about 70 to 80% indoor coverage, as I'm sure many of you know from trying to use your cell phone in your home. So it needs to provide significantly better coverage than cellular systems. And it needs to be global. It needs to be global, as I said, because of the economies of scale, but also many of the applications themselves are inherently global. So automotive, for example, is an application that is inherently global. And indeed, even some of the healthcare applications are global. If you have some sort of monitor that you're wearing, you want it to work even when you go to different countries. So that's what you need to deliver with machine to machine. And that's quite a challenge. So we're effectively saying that we want to be able to deliver better coverage than cellular systems for much lower cost, and for a system that can run off batteries for 10 years. That seems to be a pretty big ask. But on the upside, there's a number of factors that you can take into account when you're designing for machines. You don't need to have very low latency. You don't need the system to be able to respond in milliseconds, unlike a personal system. You don't actually need that high data rate. Your smart meter doesn't tend to care whether it delivers its data at a megabit a second or 10 kilobits a second. It doesn't really matter to it. As long as it gets its data across within the allotted time for delivering that particular reading, the data rate is utterly irrelevant. And you can schedule the traffic a lot more. So with personal communications, you have no idea when somebody wants to make a call or browse the internet. With machine communications, you often know that a machine is going to deliver a particular piece of data very periodically, so a reading from a meter once every hour. So the whole thing can be very carefully scheduled and packed in place. So we came up with the system, and I won't dwell on these in great detail, because either you know enough about the wireless technology to understand it, or it would take me a lot longer than the 15 minutes I've got to explain it to you. But a hugely flexible system that works with a time division duplex, frequency hopped physical layer. And in particular, it makes use of something called spreading to extend the range of the system, which is exactly what GPS satellites do in order to get signals picked up on the ground, even though the satellite transmitter is incredibly weak, much weaker than a typical cellular tower. And using this spreading, we can actually extend the range of the system much further than a cellular system at the expense of data rate. But as I said before, that's fine for the typical machine. It doesn't need a megabit a second or more. And in particular, it's very clear to us that no wireless technology succeeds unless it's an open global standard. If you think of anything, any technology that you're used to using, Bluetooth, Wi-Fi, cellular, they're all open global standards. So right from the start, it was clear that we needed to turn this into an open global standard. And we decided to do that in exactly the same way that Bluetooth did it, which is to set up our own entity. In the case of Bluetooth, it was called the Bluetooth SIG. In our case, we've called it the weightless SIG. Weightless is the name of the technology that we're developing. I'm using that to build a new and open standard. So how does it fit with other existing standards? Well, I've layered this, you could cut this many different ways. I've layered this in terms of applications across the top: rural broadband, the wireless LAN kind of application, machine to machine and mobile broadband. And then down the side, the type of spectrum that's being used: white space, on licensed spectrum and licensed spectrum. And what you can see is that in the machine to machine area, you can make use of licensed spectrum through using cellular type systems such as GPRS, but that doesn't meet many of the requirements of the machine communication technology. Or you can use an unlicensed band with Zigbee or Bluetooth, but those are both very short range, typically only 100 meters or so. Weightless fits into a different space, which is long-range machine communications, but using unlicensed spectrum to bring about the low cost and the long range. Getting the machine-to-machine system off the ground is quite an undertaking. There's an enormous range of different machine applications, and I don't expect you to read those. In fact, even I can't from here. But it's designed to show that there's at least 100 different applications that are already envisaged for machine communications. And they span energy, consumer, healthcare, automotive, retail, manufacturing, public safety, military, and a wide range of other different camps. So an enormous range of applications. And then within that, you need people to make the chips that are going to go into whatever the devices might be, people to make the terminals, so to make the smart meter. You need someone to build the network, and you need someone to supply them with base stations and network equipment. And then you need someone to make sense of all the data that's arriving. So it would not be unusual to be generating gigabytes of data per day from a smart city. Someone needs to be able to take all that data, analyze it, and make sense of it. You need standards bodies to deliver open standards. You need regulatory bodies to look after the spectrum access and overall regulation. And then the whole thing can be tied up with governments too. So to quickly run through some of the key applications, I've mentioned some of them already. Smart metering is a very clear application for machine communications. It's something that's being rolled out right now. So the idea is that you can connect directly to a consumer's home meter. You can read that meter, but you can also start to do cleverer things, such as turn it off if they haven't paid their bills, and eventually start to use it to control the load in the home by shutting off certain home appliances if it looks like the overall electricity demand is exceeding the supply. And that's the smart grid, and that's a very, very important goal for many governments and indeed environmentally. Smart cities are something that is much talked about now, and there's a huge wealth of different things that can be done there, from parking sensors to check whether parking spaces are empty, through to dustbin sensors that tell you when to go and empty a dustbin. In fact, we're actually doing a smart city trial right here in Cambridge. And when we talked to the Cambridge City Council and said, what's your biggest problem? They said, knowing when to empty the dustbins that sit outside industrial units, such as restaurants and so on. They get filled up at incredibly different speeds. And if they're left full, that's a real problem. And sending a lorry around every day to empty all of them is a complete waste of garbage trucks. So if you could tell exactly when each of those dustbins needed emptying, you could hugely optimize the whole process of collecting rubbish. Sounds a bit prosaic, but it's exactly the sort of thing that's needed to make cities and urban areas run much better. And indeed, you can use this for all sorts of electric vehicle charging, street light optimization, and much, much more. And then we heard this morning already about healthcare and the need for remote monitoring to allow people to live longer in their homes. And that kind of thing can be done very well with machine communications. And logistics, just tracking things is a real issue. Tracking containers turns out to be a really big problem. And if you could have a simple device that you could just attach to every single container, it worked wherever it was in the world, and it worked for the life of the container or thereabouts, that would be a huge potential saving to a very wide range of companies. So there's a huge amount of different applications for some kind of low-cost, wide area machine communication system. So what's the difficulty in doing that? And in particular, what's the difficulty in doing that for a company that 18 months ago was a startup? We now have 40 people, but even so, trying to convince the world that our technology and our standard is going to be the standard for the whole of the world for all machine communications is pretty tricky. And so trying to find a way to leverage, as we heard this morning, all the other different kinds of systems that you can use. If we could do as well as we heard this morning and generate global publicity for 30k euros, then that would be fantastic. We've not quite managed to achieve the same excitement with machine communication systems as Spotify did with music yet, but you never know. Another big problem is actually trying to persuade the large companies to join. In a way, we don't need them particularly to deliver the technology, but they bring an enormous badge of credibility to the project. If you can point to a number of big companies and say, look at these big companies, they're part of what we're doing, then that really helps with the overall sale of the standard. But large companies tend to be rather risk averse. They take a long time to make decisions, and they often say, well, we'll sit on the sidelines and wait and see what happens with this one, rather than engage early. So that's a particular issue. Getting SMEs involved is not a problem at all. We're delighted with the amount of interest from small companies that want to be involved in this. The problem is actually handling the large number of them. So most of our team are doing technology development. There's only 3 or 4 that are actually handling sort of external liaison. And if we've got 5 or 10 SMEs a day coming to us and saying we want to be part of this, then clearly we've got a big problem in handling that. So actually, it's the flip side with SMEs. And what works really well is those that can come to us and say, we know what we want to do with this, it's X, can you help us? Rather than the ones that come to us and say, this sounds really interesting, tell me more about it, I'd like to learn all about your technology. And we'd be delighted to tell them, but of course that takes a lot of time and a fair amount of effort. We also need to cover the world. It's meant to be an open global standard, and it's easy enough to meet in Cambridge and London, but the time it takes and the cost of going all around the world is an issue. And we've got all those different application areas, and we need to decide, do we stay above all those and just say to all of them, here's this standard, this technology, make the best of it? Or do we try and engage deeply with 1 or 2 in an effort to push things forwards and try and find, if you like, a flag-bearing application that can show everyone else the way? And that's still something that we're debating. So what insights have we gleaned so far? The key insight, I think, in any wireless technology is you have to turn it into an open standard, and you have to convince the world that it is the open standard. And that means that you need marketing activity to do that. And actually, although our technology is pretty neat, I'd say actually it's more important that we get the marketing right even than we get the technology right in this case. We've got to build the mind share and the credibility. And once you start building it, you need a vehicle to manage that, something like a standards body that can draw people in and give them a route whereby they can collaborate. They're not just bystanders, but they can be part of the whole process. And eventually you hope to get to some sort of virtuous circle where you've got enough people coming in and telling all their colleagues and other people and getting enough mentions that the whole thing will take off. And you've got to do a lot of work to get to that particular point. And then once you're there, obviously, you can take your foot off the pedal in that respect, although there's plenty of other things to do, particularly in terms of the logistics of running very large numbers of entities. And in particular, we also became clear to us that we need the SMEs right at the start, because they're the only things that are going to work fast enough to get this off the ground at the speed that we need to, in order that we can start to get some payback on investment in the sort of time that the venture capital companies that are funding us are happy to accept. And that, of course, then just comes back to the manpower of trying to do everything, be everywhere, and try and talk to every interested party, which is the biggest challenge that we face. That's more or less it. If you want to find out more about what we're doing, as I said, we have got a standards body, the Waitlist SIG, and you can find out a lot more details about that at the address waitlist.org, and there's all sorts of information there. There's also a book on waitlists, which you can get through Amazon or anywhere else, Understanding Waitlists, that describes the systems and the applications in a lot more detail. And that's me done.
Thanks, William.
Thank you, Dan.
Any questions for William? There's one there.
Yeah, right. It's just really to ask you that, I mean, trying to do something which is an international standard,
Yes.
and therefore you want lots of people to adopt it, where do you make your money?
We expect to sell the core network software that's required to keep all the base stations working properly. So that's essentially where we're expected to make money. But because we've decided to make an open global standard, and you didn't mention it, but in fact a royalty-free open global standard, we've deliberately given up the possibility of using our IPR to make money on terminal sales. And we think that's the right way to go here to keep the costs as low as possible. And also, I call it the Adobe strategy. You give away the reader, and the writer becomes quite a valuable tool if everyone's got the reader. If you charge £100 for the reader, you'll never get off the ground in the first place. So the basic answer is the core network software and systems that are needed to run these networks.
It sounds like a global SCADA network.
Yes.
Phrase.
Yes.
Which is amazing. But SCADA has recently been getting some bad press because of security breaches.
Yeah.
How do you overcome all of that?
So one of the requirements I didn't mention was very good security. So right from the start, we knew that we had to design in extraordinarily good security, both in terms of encryption, but actually even more so in terms of authentication. In a way, the worst thing is to be able to impersonate somebody else's electricity meter or whatever and then send in bogus readings. So the first thing we did was actually set up a security subgroup of security experts to define the security standard to apply to this. And we've adopted a number of, sort of US mandated type of systems from a body called NIST, which should be more than adequate to handle security in this space. We'll be doing all the standard stuff of opening this up to everyone to try and crack to see if they can before the system goes live. But you're quite right, a very important requirement.
Thanks very much, William. Quick one.
I'm Peter Howard from Technology Business Development. We work with companies to help them to commercialise new technology areas. Given the audience and the breadth of the people we have here, is there a particular challenge that you would like some interactive input on that the guys from the creative industries here might be able to assist you with?
I think there's perhaps two areas. One is, and if there's any particular application space that this could be used in, that it could be trialed and deployed early because it seems useful for that particular application space, then it would be really helpful to work with that and dig into that application. The second is more generally whether we can make better use of creative industry thinking to build interest in what we're doing and publicise what we're doing and just evangelise and draw people in and make it a bigger community in that space. So I think those are the two key challenges.
How are you deciding at the moment how deeply to go into those areas that you are deciding to engage with? What's your model?
It's a pretty simple model actually. It's the sort of what I call the low-hanging fruit model, which is we cast around fairly generally with the few of us that there are, and anything that looks like it's relatively easy to grab, either because it's happening or because there's somebody there in a different company who's really interested in what we're doing, we tend to leap onto that.
Some money.
Yeah, exactly. It's not the most scientific of approaches. We haven't surveyed every application, but.
Okay, thank you.
Okay, thank you very much.
Thank you.
One more, yeah.
One very quick question. Just say
Sure.
something about when.
Yeah, the standard will be completed first quarter of next year, and the first chipset will be available shortly afterwards. So we should be able to have large-scale trials by first half of next year, and we expect to see real ramping of volumes in 2014.
I've got a follow-on question. How easy will it be to integrate with your systems, assuming you're running all of the base network, and how do we get the hardware?
We are right now just developing a developer board, which is a small board about that big, that any developer will be able to buy for a few $100s and essentially plug in and play. There's a network running around Cambridge, so anyone who wants to bring the system here to actually run on a live network can do that.
Okay. Do we have to plug into your kind of back-end servers or anything? Or is it
Not particularly.
peer-to-peer?
Actually. It's not peer-to-peer, but we can kind of make available simple connectivity.
Sounds
out the
like,
other
William,
side.
there's a conversation
Yes.
you have offline.
Yes.
That's good.
Definitely.
That's good. Thank you very much, William.
Thank you.